Hi everyone, it's Coach Fred here, and today I'm going to be talking about similarity in triangles. In general, you should know that proportional reasoning is just such an important skill for you in high school math and in life. Most things aren't ever really equal, they are proportional. So I'm going to spend time today talking about similarity in triangles, a topic that you learned about in geometry. And you have to apply on standardized tests, and it's definitely something that you'd be using if you ever go into engineering of any kind. All right, so let's look at this triangle here. I immediately know there's a small triangle. Immediately see a small triangle and a large triangle, but I actually also know that they're similar. How do I know that? Well, these symbols right here mean that the lines are parallel. So that tells me that this angle and this angle are corresponding, so they're equal. I also can see then that this angle and this angle are equal. So what that tells me is that the triangles are similar by a theorem you learned in geometry called the angle-angle similarity theorem, or postulate, depending on which book you used. So that tells me that the triangles are similar, which means their sides are in proportion. Now, there's many ways to do this. If you're trying to find EC, you can give it a value of x. The triangle proportionality theorem would tell me then that 4 over 8 would equal x over 12. So 4 over 8 equals x over 12. I would simplify that ratio on the left to 1/2. And then I can see that 2 times 6 gives me 12. And so 1 times 6 would give me 6. And so this length would be 6. Very, very basic example. Another way to think about similar triangles is to separate them. Okay? If I took this small triangle, and that we call DCE, this would be 4. And I make the big triangle. This would be B, C, and A. Then this would be 12, because 8 plus 4 is 12. And this side then would be x plus 12. So you have to be really careful, but it is another way if you wanted to separate the triangles to find the little pieces of the triangle. All right, here's another example. Now I split this up, I put it sideways, but I want you to immediately see that these lines are parallel, so therefore this small triangle is proportional or in proportion to the large triangle, even if it's sideways. I would tell you this, most of the triangles that are on the ACT in particular are similar, as well as the SAT. All right, so here's a great question. In the figure below, triangle ABC and triangle DEF are similar. Find the perimeter of DEF. Okay, so you can see that in triangle ABC, I gave you some side lengths, 6, 6, and 10. And we're saying that these triangles are similar. So what you have to do is you have to figure out what the missing sides would be in the triangle. And in looking at this, I can see that the one longer side, the other two sides are equal, and that the longer side is the one that is on its own. So already I know that 5 has to be the longest side of this triangle, so then these two would be 3. And therefore, it would be, the perimeter would be 11. That's a nice, basic, easy example. You can also use similarity to solve more like word problems where they say, a man is standing next to a tree and you're trying to find the height of the tree. Similarity is a way to use to find heights of things. Now, they would be estimates, of course, but you can see that we have a triangle here and we have a triangle here. So the tree is perpendicular to the ground and the person is perpendicular to the ground. We can also see that these angles of reflection are equal, so the triangles are similar. So we can give this a value of x, and we could say 6 over 2 equals x over 24. Again, I would simplify 1 and 3, and so x would be 72, because you'd multiply 3 by 24. And so the height of the tree would be 72 feet. All right, so that's just some basics. I do want you to also recognize the fact that when you're using right triangle trigonometry, the triangles are actually in proportion, which is why why these proportions, these trigonometric ratios work. The triangles are not always equal, but the ratios, the side lengths of those right triangles are still in proportion. But I'm going to go into that in another video. This was just a basics on triangle similarity. Have a great day.